Hello, in this lecture we will find the value of x in two different methods. In the drawing we have quadrilateral SRPQ. We know that angle SRP equals to 65 degrees, angle PRQ, this angle equals to 50 degrees, and we also know that side SP equals to side SQ, and we want to find out the value of angle PSQ, this angle that is also defined as x. So we'll start with the first method, and we will actually extend side QR. We will extend side QR, and then from point S we will draw perpendicular to the extended QR, to the extended side QR. So actually we will define this point as point N, and actually angle SNR equals to 90 degrees because SN is perpendicular to the extended QR. Therefore this angle SNR equals to 90 degrees. Then we will also draw a second perpendicular from point S. From point S we will draw perpendicular to PR. And we will define this point as point M. So SM is actually perpendicular to PR, therefore this angle equals to 90 degrees, angle SMR equals to 90 degrees. And then we will focus on the right triangle SNR, and the right triangle SMR. Okay, so we will focus on those two right triangles. First of all, SR is a common side, it belongs to both triangles, to the right triangle SNR and to the right triangle SMR, so SR equals to SR. It is a common side. and actually we extended QR. So actually QN is a straight line. We extended QR, so QN is a straight line. Therefore, and we know that the sum of the angles on a straight line at any point equals to 180 degrees. Therefore, at point R on the straight line QN, the sum of the angles must be equal to 180 degrees. Therefore, we have here 50 degrees. If we focus on point R, we have 50 degrees plus 65 degrees plus the size of this angle, I will call it angle Y, must be equal to 180 degrees. Okay, so along the straight line QN, the sum of the angles must be equal to 180 degrees. Therefore, the sum of the angles along the straight line QN at point R must be equal to 180 degrees. That is to say, 50 degrees plus 65 degrees plus the size of this angle Y, must be equal to 180 degrees. So here we will subtract 50 degrees from this equality, and we will get that 65 degrees plus Y equals to 130 degrees. So here we will subtract 65 degrees from this equality, and we will get that Y equals to 65 degrees. So we actually found out that this angle equals to 65 degrees. Okay, so we actually know that angle SRM of triangle SMR, angle SRM equals to angle SRN and both those two angles are equal to 65 degrees. Okay, so angle SRM from triangle SMR equals to angle SRN from triangle SNR, and both angles are equal to 65 degrees. And we also know that those two angles are also right angles. So angle SMR, this right angle, equals to angle SNR, and both those two angles are equal to 90 degrees. Okay, angle SMR equals to angle SNR, and both those two angles are equal to 90 degrees. And actually, we also know that the sum of the angles in any triangle equals to 180 degrees. So if we focus on triangle SMR, the right triangle, triangle SMR, we know that in triangle SMR, the sum of the angles must be equal to 180 degrees. That is to say 90 degrees plus 65 degrees plus the size of this angle that I will call it angle Z must be equal to 180 degrees. Again, the sum of the angles in the right triangle, triangle SMR must be equal to 180 degrees. So here we will subtract from this equality 90 degrees, and we will get that 65 degrees plus Z equals to 180 degrees minus 90 degrees is 90 degrees. So we got that 65 degrees plus the size of angle Z equals to 90 degrees. Here we will subtract 65 degrees from this equality, and we will get that angle Z equals to 90 degrees minus 65 degrees is 25 degrees. Okay, so we found out that angle Z equals to 25 degrees. So this angle equals to 25 degrees, and we know that the sum of the angles in the right triangle, triangle SNR, also equals to 180 degrees, and it has exactly the same angles of triangle SMR. That is to say, it has angles 65 and 90 degrees. Therefore, this angle SR will be NSR will be also equal to 90 degrees. So we actually found out that angle MSR equals to angle NSR, this angle, and both those two angles are equal to 25 degrees. So angle MSR of triangle MSR equals to angle SNR of triangle SNR. Therefore, we actually proved that triangle SMR is congruent triangle SMR congruent to triangle, that is the sign of congruent of triangle SNR. So those two right triangles congruent to each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if you prove that two angles or and one side of a triangle are equal to two angles and one side of other triangle, then you proved that those two triangles can go into each other according to angle side angle rule. Okay? So from the fact that the right triangle SMR congruent to the right triangle SNR, we can conclude that we can conclude that S So from the fact that triangle SRM congruent to triangle SNR, we can conclude that SM equals to SN according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, so in the next step we will focus on triangles, the right triangle, triangle SPM and triangle SNR and triangle SMQ. Okay, so we will focus on triangles SPM and SMQ. We know that side SP equals to side SQ, SP equals to SQ, and we also know that SM equals to SN, and actually PM equals to NQ. PM equals to NQ, PM equals to NQ. So I will prove that PM equals to NQ. Actually, according to Pythagorean theorem, PM equals to the root of SP square minus SM square. Again, PM equals to the root of SP square minus SM square. And what is the value of NQ? NQ, according to the Pythagoras theorem, the value of NQ, it equals to the root of SQ square minus SN square. Okay, NQ equals to the root of SQ square minus MP square minus SN square. Again, NQ, according to the Pythagoras theorem, equals to the root of SQ square minus SN square. But we know that SP equals to SQ. It is given us in the question that SP equals to SQ or QS, it is the same. And we also know that SM equals to SN. We already found out that SM equals to SN, so actually those two expressions are the same expressions. Therefore, PM equals to MQ. PM equals to NQ. Therefore, triangle SPM can go end to triangle SNQ according to side rule. Okay, triangle SPM can go into triangle SNQ according to side rule. Triangle SPM, this right triangle can go into triangle SNQ according to side rule. So because of the fact that the triangle SPM can go into triangle SNQ, angle SPM will be equal to angle NQS. Angle SPM, this angle, equals to angle NQS, this angle. And if we define angle SPM as theta, then angle NQS will be also equal to theta. Okay? And we also have a rule that states that if a line segment subtends two equal angles, on the same side, then the 4 points lie on a circle. So I will read the rule again. The rule states that if a line segment subtends two equal angles on the same side, then the 4 points lie on a circle. So actually, if we have a line segment here, actually we have line segment SR. On line segment SR we have two equal angles. Those two angles that are both equal to theta are both subtend on the line segment SR. Therefore, according to the rule that I stated, those 4 points, point Q, point P, point Q, point R, and point S, lie on a circle. So actually we can put those 2 points on a circle according to the rule that I stated, because of the fact that those two angles are equal to each other and they are both lie on the same, and they are both subtend on the same line segment. That is to say, they are both subtend on the line segment SR. So actually, therefore both those therefore the 4 points P, Q, R, and S lie on a circle. So points SR, P, and Q lie on a circle. So we have here point SR, so according to the rule that I read, because of the fact that those two angles that are both equal to theta subtend on the same line segment, that is to say on SR, this angle theta subtend on SR, and this angle theta subtend also on line segment SR. Therefore, those two 4 points P, Q, R, and S lie on a circle. Okay? And we actually have another rule that states that peripheral angles that subtend on the same chord are equal to each other. Okay? Peripheral angles that subtend on the same chord are equal to each other. So I'll read the rule again. The rule states that peripheral angles that subtend on the same chord are equal to each other. So here we have two peripheral angles that subtend on the same chord PQ. Angle X subtend on chord PQ, and this angle that equals to 50 degrees also subtend on the same chord PQ. Therefore, those two angles are equal to each other. That is to say, angle X equals to 50 degrees. Angle X equals to 50 degrees. Okay, so we found out that the angle that we are looking for, that is to say angle X, the side of angle X is 50 degrees. And that is the answer to the question. Okay, so angle X equals to 50 degrees. Okay, so in the next step we will find the value of angle X in a second method. Again, we will find the value of the size of angle X, this angle, according to a second method. On the second method, we will extend SR. We will extend SR, and then we will draw perpendicular from point Q to the extended SR. So this angle is a right angle because we drew perpendicular to the extended SR. We will define the touching point between the perpendicular to the extended SR as point M. So this angle equals to 90 degrees. Then we will extend QM until actually it will be equal to QM until Q des we'll extend QM until Q des in such a way that Q des M will be equal to MQ. Okay, Q des M equals to QM. So Q des M equals to QM. That is according to our construction, Q des M equals to QM. Then we will join points R and Q des together by a straight line. We join together points R and Q des by a straight line. We will also join together points S and Q des by a straight line. Then we will focus on, actually we know that Q des is a straight line. Q des is a straight line. Therefore, and we know that rule that states that the sum of the angles on any point along a straight line equals to 180 degrees. Therefore, if we focus on point M on the straight line Q des, the sum of the angles at point M along the straight line Q des equals to 180 degrees. That is to say, this angle is the right angle, it equals to 90 degrees. Plus the size of this angle, that equals to y. We'll define this angle as angle y, must be equal to 180 degrees, according to the rule that the sum of the angles along a straight line equals to 180 degrees. Okay, so we got that 90 degrees plus y equals to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that y equals to 90 degrees. Okay, y equals to 90 degrees, therefore angle Q des MR is a right angle. Okay, angle Q des MR is a right angle, that is to say it equals to 90 degrees. So in the next step we will focus on the right triangle QRM. So in triangle QRM and the right triangle Q des RM. Okay, we'll focus on the right triangles QRM and Q des RM. On those two right triangles, we know that QM equals to Q des RM, that is according to our construction. QM equals to Q des M. So those two sides are equal to each other according to our construction. we build Q dash M in such a way that it will be equal to QM. Okay? So QM equals to Q dash M. We also know that those two angles are equal to each other and they are both equal to 90 degrees. So angle QMR equals to angle Q dash MR, and they are both equal to 90 degrees. So angle QMR equals to angle Q dash MR, and they are both equal to 90 degrees. And side RM is a common side, it belongs to both triangles, so we can write down that RM equals to RM. It is a common side. RM equals to RM, it is a common side, it belongs to both triangles. So side RM equals to side RM, it's a common side that belongs to both triangles. So we actually proved that triangle QMR congruent to triangle Q dash MR according to angle side rule. Again, we proved that triangle QMR congruent to triangle Q dash MR according to side rule. So what is side rule? Side rule is that if you prove that two sides and the angle between them are correspondingly equal to two sides and the angle between them on the other triangle, then you proved that those two triangles congruent to each other according to side rule. Okay? So, from the fact that those two triangles congruent to each other, we can conclude that those two sides are equal to each other. QR equals to Q dash R. QR equals to Q dash R according to the rule that states that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding sides will be equal to each other. So QR equals to Q dash R. Okay, we know that SP equals to SQ, it is given us in the question. So because of the fact that SP equals to SQ, we can define SP as Y, then SQ will be also equal to Y because of the fact that those two sides are equal to each other. So in the next step we'll focus on the two big right triangles, triangle SMQ, the big right triangle SMQ, and the big right triangle SMQDES, this triangle, SMQDES. They are both right triangles. On those two triangles, we know that QM equals to QDESM, that is according to our construction. QM equals to QDESM according to our construction. QM equals to QDESM according to our construction. Those two angles are both right angles and they are equal to each other. So angle QMS equals to angle QDESMS, and both those two angles are equal to 90 degrees. Okay, angle QMS equals to angle QDESMS, and both angles are equal to 90 degrees. And side SM is a common side, it belongs to both triangles. So we can write down that SM equals to SM. It's a common side. It belongs to both triangles, so SM equals to SM. So we actually proved that the triangle SMQ is congruent to triangle SMQDES according to side angle side rule. So I'll write it down. Triangle SMQ congruent to triangle SMQDES according to side angle side rule. So what is side angle side rule? If you prove the two sides and the angle between them in one triangle are correspondingly equal to two sides and the angle between them of the other triangle, then you prove that those two triangles can go into each other according to side angle side rule. So from the fact that triangle SQM can go into triangle SMQDES, you can conclude that side SQ equals to side SQDES. SQ, this side equals to side SQDES. Okay, SQ equals to SQDES according to the rule that corresponding sides in congruent triangles are equal to each other. But we know that side SQ equals to Y, therefore side SQDES will be also equal to Y. Okay? So in the next step we will focus on triangles SQR and triangle SQDSR. Again, we will focus on triangles SQR and triangle SQDSR. Actually, on those two triangles, we know that SQ equals to SQDES, SQ equals to SQDES, we have already proved here that SQ equals to SQDES, and we have already proved that QR equals to QDESR, QR equals to QDESR, okay, QR, side QR equals to side QDESR, and SR is a common side, it belongs to both triangles, so SR equals to SR as common side. Okay, so we actually proved the triangle SQR can go into triangle SQDESR according to side rule. Okay, triangle SQR can go into triangle SQDESR according to side rule. I read again. Triangle SQR can go into triangle SQDESR according to side rule. So what is side rule? If you prove that all the sides of one triangle are correspondingly congruent to all the sides of another triangle, then you prove that those two triangles can go into each other according to side rule. So, from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define this angle as theta, then this angle will be also equal to theta. Okay? And actually PR is the diagonal of quadrilateral SRPQ. Okay, so we know that therefore PR as a diagonal is a straight line. Okay, PR is a straight line, Again, PR is a straight line. So why PR is a straight line? Because of the fact that PR is a diagonal of quadrilateral SRPQ, therefore it must be a straight line. And we also know that RQ dash is one side of triangle MRQ dash. Again, RQ dash is one side of triangle MRQ dash, therefore RQ dash is a straight line, okay? RQ dash is a straight line. So we found out that PR is a straight line and RQ dash is a straight line. But before I continue, actually we proved that the right triangle QRM is congruent to triangle RMQ dash. Okay, but before that we extended SR until point M. So because of the fact that we extended SR by a straight line, SM is a straight line, and the sum of the angles on a straight line equals to 180 degrees. So we have here 65 degrees plus 50 degrees plus the size of this angle must be equal to 180 degrees. So this angle must be equal to 65 degrees in order to complete the sum of the angles on the straight line SM at point R to 180 degrees. This angle must be equal to 65 degrees. Okay? And we have already proved that triangle RMQ is congruent to triangle RMQ dash. Therefore, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other. We have already proved it. Therefore, those two corresponding angles will be also equal to each other. So if this angle is 65 degrees, this angle must be also equal to 65 degrees because of the fact that those two angles are equal to each other. So this angle equals to 65 degrees. And we actually proved that PR is a straight line and Q dash R is also a straight line. But what is the what about line Q dash? If we prove that at point R the sum of the angles is 180 degrees, we actually will prove that PQ dash is a straight line. Why? Because PR is a straight line and Q dash R is a straight line. And the only thing that is left in order to prove that PQ dash is a straight line is to prove that at point R the sum of the angles is equal to 180 degrees in order to prove that PQ dash is also a straight line. So what are the angles at point R? The sum of the angles at point R is actually 50 degrees if we look only of one side, of course. 50 degrees plus 65 degrees plus 65 degrees. So the sum of the angles at point R is equal to 50 degrees plus 65 degrees plus 65 degrees. 65 degrees plus 65 degrees is 130 degrees, and 130 degrees plus 50 degrees is 180 degrees. Therefore, at point R, the sum of the angles is equal to 180 degrees. So what is angle 180 degrees? Any angle that equals to 180 degrees is a straight line. So actually here we have a straight line. Okay, so at point R we have a straight line. Okay, at point R we have a straight line, and we also proved that PR is a straight line, and RQ dash is also a straight line, and at point R we have a straight line. Therefore, we actually proved that PQ dash is a straight line. PQ dash is a straight line. Okay, PQ dash is a straight line. Therefore, the structure PSQ dash is a triangle. Therefore, the structure PSQ dash is a triangle. Because of the fact that PQ dash is a straight line, we can conclude that the structure PQ dash S is a triangle. Okay? So PSQ dash is a triangle, and in triangle PSQ dash we have two sides that are equal to each other, and according to the rule that in front of equal sides in the triangle we have equal angles, those two angles that are located in front the equal sides y and y will be also equal to each other. Therefore, if this angle is theta, this angle also must be equal to theta. Okay? So here we have two equal angles that are located on the same segment that subtend those two equal angles that are both equal to theta. They are both subtend on the same line segment. That is to say, they are both subtend on the line segment SR. Okay? Because of the fact that those two equal angles, they are both subtend on the same line segment SR, we can conclude that the 4 points P, Q, R, and S are they are on a circle. Okay, so we can put points S, R, Q, P on a circle because of the fact that those two equal angles subtend on the same segment line SR. Okay, so we actually put this structure, or we can put the quadrilateral SRPQ inside a circle. We can inscribe the quadrilateral SRPQ in a circle. Okay, so here I will draw a circle with those 2 points, with those 4 points S, R, P, and Q on the circle that I will draw. So we have those 2 points, those 4 points S, R, P, and Q. They are on the circle that I will draw. So I will repeat on the rule that I stated again. We have those two angles that are equal both to theta. Those two angles subtend on the same chord, on the same segment line SR. Therefore, those 4 points are located on a circle. You can put those 4 points on a circle that inscribes this quadrilateral, according to the rule that is stated that if you have 2 equal angles that they are both subtend on the same segment line, that is to say on SR, then you can put those 4 points on a circle, or those 4 points inscribed by a circle, or those quadrilateral inscribed by a circle. Okay, and we have the second rule that I stated, that peripheral angles that subtend on the same chord, they are equal to each other. So we have those two peripheral angles and they are both subtend on chord PQ, therefore they are equal to each other. Therefore the size of X is exactly at the size of 50 degrees, or X equals to 50 degrees. Okay, so we found out that X equals to 50 degrees. Okay, so now I'll summarize the lecture. So actually wanted to find out the value of X. We have here quadrilateral SRPQ. We want to find out the value of angle PSQ or X. Okay, we know that angle SRP, this angle equals to 65 degrees, and we also know that angle PRQ, this angle equals to 50 degrees, and we also know that SP equals to SQ, and we want to find out the value of X, or the size of angle X. Okay, so first of all we did a construction. We extended QR, and then from point S we drew perpendicular to the extended QR, and we defined this point as point N. So angle SNR equals to 90 degrees. Okay, then we drew perpendicular to PR. We defined this point as point M, so this angle is 90 degrees because of the fact that this is the perpendicular to PR. Therefore this angle equals to 90 degrees. Okay, then we actually proved that those two right triangles can go into each other. So first of all, they have those two angles that are equal to each other. They are both equals to 65 degrees, and they have also two right angles that are equal to each other. So we know that the sum of the angles in any triangle equals to 180 degrees. So here we have 90 degrees in triangle MSR, this triangle. We have 90 degrees plus 65 degrees is 155 degrees. So the third angle must be equal to 25 degrees in order to complete the sum of the angles on the right triangle SMR to 180 degrees. And therefore, in the right triangle SNR, this angle must be also equal to 25 degrees because of the fact that we have 65 degrees, 90 degrees, and this angle must be also equal to 25 degrees in order to complete the sum of the angles on the right triangle SNR to 180 degrees. So, in the right triangle SMR and triangle SNR, we have three equal angles, or three angles that correspondingly equal to each other, and we have also common side. Side SR is a common side. It belongs both to triangle SNR, and side SR also belongs to the right triangle SMR. So we can conclude that triangle SMR can congruent to triangle SNR according to angle side angle rule. Okay, so those two triangles can congruent to each other. So from the fact that those two right triangles can congruent to each other, we can conclude that NS equals to MS. NS equals to MS. Those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can congruent to each other, therefore those two corresponding sides will be also equal to each other. So SM equals to NS. Okay. SN equals to SM. And then we focused on the right triangles PSM, and the right triangle SNQ. On those two right triangles, we know that SM equals to SN. We also know that SQ equals to SP. It is given us in the question. And we have also the third side. So SN equals to SM, QS equals to SP, and also QN equals to PM. So why QN equals to PM? Because of the fact that we are talking about right triangles, and if you have two sides that are equal to each other in a right triangle, the third side also must be equal So actually, if we want to prove that PM equals to NQ, we actually proved that PM equals to NQ according to the Pythagoras theorem, the value of PM is actually the root of SP square minus SM square. The value of PM is the root of SP square minus SM square. And what is the value of NQ? The value of NQ is the root of SQ square minus NS square. Okay, the value of NQ is the root of SQ square minus NS square. But we know that SP equals to QS, it is given us in the question, and SM equals to NS. SM equals to NS, we have already proved that N equals to SM, so actually those two expressions are the same expressions, therefore PM equals to NS. Okay? So we actually proved that the right triangle SMNQ is congruent to the right triangle PMS. Okay? According to side rule. Okay? And here we know that after we extended QR by a straight line, we created segment line QN that is also a straight line. So at point R, the sum of the angles must be equal to 180 degrees. So 50 degrees plus 65 degrees plus the size of this angle must be equal to 180 degrees. Therefore, this angle must be equal to 65 degrees in order to complete the sum of the angles at point R along the straight line QN to 180 degrees. So this angle equals to 65 degrees. Okay? And then because of the fact that triangle SNQ is congruent to the right triangle SPM, those two right triangles congruent to each other according to side rule. Therefore, those two angles must be also equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So those two triangles congruent to each other, and according to side rule, therefore those two corresponding angles must be also equal to each other. Okay? So if one of the angles is theta, then the other angle must be also equal to theta. Okay? And we have a rule that states that if a line segment subtends two equal angles on the same side, then the 4 points lie on the same circle. The 4 points lie on a circle. So we have those two angles, they are both equal to theta, and they are both subtend on the segment line SR. Therefore, according to the rule that I read, those 4 points P, Q, S, and R lie on a circle. Okay? So we actually can put angles points S, R, P, and Q on a straight line. Why? Because of the fact that those two angles that are equal to each other, they are both equal to theta, They are both lie on the same segment line SR, therefore those two four angles lie on the circle. Okay? Or we can say that the quadrilateral SRPQ can be blocked by a circle. It is a cyclic, or it can be blocked by a circle. Okay? So we have here a circle, and in this circle we have those two peripheral angles that subtend on chord PQ. And according to the rule that peripheral angles that subtend on the same chord are equal to each other, those two angles must be equal to each other. That is to say, angle X equals to 50 degrees. Okay? So that was the first method. So I will explain the second method also. So in the second method actually we extended SR by a straight line, and then from point Q we drew perpendicular to the extended SR, so this angle equals to 90 degrees, and we define the touching point between the perpendicular to the extended SR as point M, and then we extended QM until point Q dash in such a way that Q dash M will be equal to QM. Okay, so according to our construction, Q dash M equals to QM. Then we join together by a straight line points R and Q dash, and we join together by a straight line points S and Q dash. And here, what is the size of angle Q dash MR? We know that Q dash or Q dash is a straight line, and the sum of the angles on a straight line at any point on the straight line equals to 180 degrees. So at point M, the sum of the angles must be equal to 180 degrees. But we know that this angle is 90 degrees. We will define this angle as Y, so 90 degrees plus Y must be equal to 180 degrees. Okay, 90 degrees plus Y must be equal to 180 degrees. We will subtract 90 degrees from this equality, and we will get that angle Y equals to 90 degrees. So we actually found out that this angle is a right angle. So here we have two right angles. Okay. Then we focused on the right triangles QRM, and on the right triangle Q dash RM. We know that QM equals to Q dash M according to our construction. Q dash M equals to QM. We also know that those two angles are equal to each other. They are both equal to 90 degrees. And side RM is a common side. It belongs to both triangles. So we can write down that RM equals to RM. So we actually proved that triangle QRM can go into triangle Q dash RM according to side angle side rule. We proved that those two sides and the angle between them are equal correspondingly to those two sides and the angle between them on those two triangles. Therefore, we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two right triangles can go into each other, you can conclude that QR equals to Q dash R. Okay, from the fact that those two right triangles can go into each other, we can conclude that QR equals to Q dash R. Okay, then we focused on the right triangle, the big right triangle, triangle QMS, and on the big right triangle, triangle Q dash MS. Okay, so on those two right triangles, we know that QM equals to Q dash M, and we also know that those two angles are equal to each other. They are both equal to 90 degrees, and SM equals to SM. It is a common side. It belongs to both right triangles. Therefore, we actually proved that the right triangle, triangle SMQ, is can go into triangle SMQ dash according to side angle side rule. We proved that those two sides and the angle between them are equal to those two sides and the angle between them on both those two triangles. Okay, so those two triangles can go into each other. Therefore, SQ be equal to SQ dash, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other. Therefore, those two corresponding sides will be also equal to each other. That is to say, QS will be equal to Q dash S. Again, Q dash S will be equal to QS according to the rule that corresponding sides in congruent triangles are equal to each other. So, if this side equal to Y, then these sides will be also equal to Y, and those two sides are equal to each other. Therefore, if this side is Y, this side will be also equal to Y. Okay? Then we have to prove that PQ dash is a straight line. In order to prove that the structure SPQ dash is a triangle. So we know that PR is the diagonal of the quadrilateral SRPQ, and as a diagonal it is a straight line. And we also know that RQ dash is one side of the right triangle, triangle RQ dash M. Therefore, it must be also a straight line. But we have actually two straight lines that touch each other at point R. So, in order to answer on the question that whether if Q dash P or PQ dash is a straight line, we must check what is happening at point R. If the sum of the angles at point R is 180 degrees, then PQ dash must be a straight line because of the fact that PR is a straight line and RQ dash is a straight line, and at point R, if we have 180 degrees, so here we have also a straight line, therefore PQ dash will be one big straight line. So we must check what are the angles at point R on this side of the drawing. Okay? So what are the sum of the angles at point R? The sum of the angles are actually 65 degrees plus 65 degrees plus 50 degrees. That is to say 180 degrees. So we proved that at point R we have 180 degrees, therefore at point R we have a straight line, therefore we actually proved that PQ dash is a straight line, therefore the structure PQ dash S is a triangle. Okay, the structure PQ dash is a triangle, and in triangle PSQ dash we have two sides that are equal to each other. And we have a rule that states that in front of equal sides in a triangle there are equal angles. Therefore, those two angles that are located in front the equal sides, in front those two equal sides must be also equal to each other. Therefore, if this angle is theta, this angle also must be equal to theta. Okay, and then we have those two equal angles, they are both equal to theta, that subtend on the segment 9SR. And we have the rule that if you have two equal angles that subtend on the same line segment from the same side, then those 4 points P, Q, R and S can lie on a circle. Okay, so we can draw here a circle. We know that points S, R, Q and P lie on a circle. Okay, but we also know that peripheral angles that subtend on the same chord equal to each other. So those two peripheral angles, angle X and 50 degrees, lie or subtend on the same chord, that is to say they are both subtend on chord PQ. Therefore they are equal to each other, that is to say X equals to 50 degrees. Okay, we found out that X equals to 50 degrees also according to the second method. Okay, thank you very much.